to see it. So basically we were trying to see the correspondence or we were trying to look at these two processes, right? Field extensions and subgroups. So I think one of these directions would have been clear, which was, well, before that, the setup. So the setup was we took a field E. Last time we took a concrete example and we showed, but today let me begin. I presume you would have seen more examples. So to begin with, let's begin more abstractly. So we had two fields to begin with. Now when we say field extensions, I mean sub extensions really. Okay. So if I take some sub extension, let's say f prime, then so I forgot one more thing. So given a field extension, we get a group. Okay. So the group maybe I'm writing at the bottom, ot E over F. So we have defined this last time. Now when you take a sub extension, then how do we get a subgroup? So can you tell us? Given this sub
Subgroup
extension,
of which one?
there is only one group I can see, so I suppose it will be subgroup of this.
Acha,
I mean, that's the assumption, right? So we did this last time abstractly, and we also saw the example. Think and say.
एक- हम वो कर सकते हैं कि नहीं एक मिनट
So you see, the question is, I want a subgroup.
ऑटोमॉर्फिज्म ई mod f dash
Okay, so what is mod?
मतलब e over
Yeah,
f
so
dash
any symbol that looks like this is not mod, right? You know that. So yeah, you see, the point is that if you say mod and if you think of it as mod, then you'll get confused yourself, right? So it's not mod,
yes
it's E over F, and the meaning is automorphisms of E which fix F prime, or in this case fix F. Right, but yeah, but anyways, the answer is how correct, as you know. So this. So you see, in this way you get subgroups. Maybe I will. So I'll not write the greater than equal to sign, but this way it's more suggestive, maybe. And you also know that at the top we have the trivial group. So can you tell me how we get the trivial group? What automorphisms should we consider? So this one
e
comes
over e
right. Yeah. So this one comes from E over E. So let me write, just keeping with the convention, E over E. So this makes it clear that you have understood how to go from sub-extensions to subgroups. Now the question is, how do you go from subgroups to sub-extensions? So if you take examples, it will be clear. But anyways, so if you take a subgroup H, so just to make sure that there is no confusion, I'm just writing here that H is a subgroup of E over F. So if from here we want a sub-extension. So what sub-extension do you think you can get?
mm,
So you want a field, right? You want a field. You just think that you want a field here. So how will you get that field from a subgroup? So you see, each sigma here in H is what? Is a function from E to E.
Yes, fixing F.
Exactly, fixing F. So how will you get a field from these functions?
तो हम कर सकते हैं कि एक सेट लेंगे इसका ऑटोमॉर्फिज्म ऑफ ई ओवर एफ, या फिर किसका फील्ड, मतलब कहाँ पे डालना है हमको फील्ड?
Field will come here, na, somewhere. It will be a subfield of E.
ओके, तो हम कर सकते हैं कि एक सेट लेंगे एस, जिसके अंदर सम ऑटोमॉर्फिज्म्स रहेंगे आउट ऑफ ई एफ डैश, ई ओवर एफ डैश का,
No,
मतलब
E over
सम
F
टाउ।
dash is not in the question. H is in the question. H is a subgroup of E over F. E over F dash is not in the question here. I
ओके,
think you can take that and give some example. I don't mind, but yeah. So see, I think it can be motivated from E over F prime also. But anyways, so this I defined last time. So this will be this is the notation we used. This is a fixed field of H, right? This is that is the answer. So this is basically all the elements of E which are fixed by every automorphism in H, right? So definition is, now you can just define it. X such that sigma x equals to x is in E and sigma is in H, right? Yeah, so we don't need to write that. This x is in E should be actually written here. But okay, it's fine. We understand that. Okay. So do you understand now?
तो मतलब मुझे ना नोटेशन से थोड़ा दिक्कत हो रहा है।
Yeah, but then you have to figure out where is the problem. Because see, mathematically I've written everything correctly and it is elementary set theory. But if you're having trouble, then you have to decipher, right? Where is the trouble? That you have to
um,
think and tell. If you just say that I don't understand, then that's not valid because this is just
ना ना ना
descriptive
ना,
set notation,
अ,
set builder form or whatever.
ओके, each है the set of all x, those are fixed by sigma, and sigma belongs to h, right?
Yes, every sigma.
Every sigma.
That is why, right? That this has to be, so this has to be true, meaning that it has to be true for every sigma because sigma, there is no condition on sigma other than that it is in H, right?
Okay. Can I have a request? Like this notation. Okay, okay, no problem. No, no issue. Okay, okay, done, done, done.
Yeah,
Sorry.
yeah. You have to, obviously, you will get confused. We all get confused when we see new notation, but that responsibility is a personal responsibility, right? To resolve that confusion because it's a elementary thing. If you, right? So that just takes some sitting down and taking an example and resolve unpacking it. Mathematics will not get easier, right? You have to get better. And that is, and this is the way you have to take more and more responsibility. about these things. Okay. So anyway, so
Yeah.
this is fine. So it's cool. Meaning, a lot of things will be not clear, but if you just sit for 5 minutes and or 2 minutes, just work it out, you will see that it's clear. So yeah. But anyways, okay. So now the maybe we'll do one example. Okay, that will be more justice about this fixed field thing. Okay, yeah. I mean, of course, we are all entitled to examples. Take some new thing, then it's good to consider examples. Let me see here if they have any examples. Yeah, they are. Hmm. So I yeah, let's take this example. So let's consider. Yes, we start writing. So you consider the field F to be Q. So through this example, we can learn many things. In particular, maybe we will get some understanding of what we discussed. Okay. So take F, and this part you might have also read this example. So take F equal to Q, and then we take a polynomial. This polynomial T. Now we take E to be. So let me just check the notation. Yes, they do not write it like that. But let me write it and see what happens. So you take E to be this. Okay. So now the question is, uh, yeah, so there is just, let's run that thing here. This example you may have seen. So what is the group of automorphisms?
Uh, Out of Q 3/2 over
Right. So
Q, then
yeah,
all those,
what is this group? Right.
yes, all those sigma.
Oh, that is
Uh,
fine. That is a definition. But what is it some group that you know? Is it some concrete group?
yes, this is a group.
Yes. So what is that group? What is the size of this group and so on? Let's think about it.
Uh, this might be a group under mm, we do functions composition. It will make a group under composition. Um,
Yes. So the things that you have said so far, they are always true. It has nothing to do with these things, right? It's true for any E over F. But we want to say things which are uh, about this particular extension. We don't want to repeat things which we already know, right? Meaning that we want to say, is this group Z3?
okay, by that way.
That is otherwise what can you say? You will say it's a group under composition, but those things you already know, right? That is always true. Why do you want to say things which you already know?
Yeah, Z3, I guess.
Right. So how do we prove it? Let's see. So we take this cube root of 2. Uh, no, I don't know if it is Z3. I think it is false. I mean, I just said it and you said yes. I don't know if it's true
No,
or
no,
not.
last time we are doing that, that was root 2 only, and we are
Uh,
telling that isomorphic to Z2.
but no, no. So that doesn't mean that this will be Z3. No.
Yeah, that extent
That
only.
doesn't mean that it is Z3. I mean, of course, that means that under some suitable conditions it will be Z3, or that means that there is something to look out for, that it is Zn this t to the power n. But it might not be true so easily, right? After all, it's anyways, yeah. So let's see. So you have attached this root. So if you have an automorphism, right, then where can this cube root of 2 go,
It can go to Q root 2 again.
right? And anything else?
Then Q root 2 omega.
Yes, but that is not there in the field, right? So it cannot go anywhere but to only cube root of 2. So this is the
Yeah,
trivial
only 2
group.
right now. Yeah.
So it's a trivial group, it is not Z3.
Mm, yes.
Okay, so that is the point.
Yes.
Okay.
Those are not available in this group. Yeah.
Huh?
Yes, the omega and omega square will won't be
Are
in
not
this.
there, and that is the
Yeah.
problem.
Yeah.
So,
Yeah.
but yeah, I mean, your guess will be correct, I think. Once you put them in this somehow, then it will be Z3, maybe.
Yeah.
But again, it has to be checked. You cannot go by, right? So
Hmm.
that is the thing. So it's more nuanced. I mean, and that is why there is something to do, right? Otherwise, what will you do? Or what will we do? I mean, otherwise everything is straightforward. So anyway, so basically here then there is nothing to do, unfortunately. Okay. So this is
Hmm.
an example of an extension which is not so interesting. So you would have seen this example, right? This is example number 1.6. Okay.
Yes, yes, I have seen.
Yeah, it is
Yeah.
seen. They have said this example in a more elaborate way, but yeah. So the degree of the extension is 3, but still it is not a normal extension. So this is an example of a not a normal extension. So when you think of non-normal, not normal, this is the first example you should keep in mind for now. Once you become
I
an
don't know about any normal extension.
so if just think that this is normal extension and this is not normal extension.
This is not normal.
When you come to the definition, then you will. Okay. Like
Okay.
something
Okay.
bad happened, right? You thought it is Z3, but it is not Z3.
Hmm.
Something like that, right? So it is so that's why it is not normal. It is a bad extension in some ways. Okay. So and normal extension is something which I did not discuss it with you. Actually, I was discussing it with someone else. I confused. I have not discussed it with you. It is something which is like if some root is there, okay, then all the roots are there. Okay, something like that, right? That is called a normal extension. Okay, that if you have a
Okay.
root of a
Okay.
polynomial which is in the field, then other roots of that polynomial should also be there. And that is broken here because cube root of 2 is a root, but cube root of 2 omega should also be a root, right? They are like partners, right? I mean, cube root of 2, cube
Uh,
root of 2 omega, cube root of 2 omega cube, omega square, these three should come
well,
together, right? You know that, but they don't appear. So that's why it's not a normal extension. And yeah, we will see the details of this. Yeah. So you see, even I did not, missed it because otherwise I didn't realize that while giving this question. I thought we will explore that thing, but I missed it. So it shows that I have also become a little uh, rusty with Calva theory. Okay. So, anyways, so we will change it, of course, because we want to see that process maybe. But I think we will not do it. It will not actually give anything nice because it will just give you Z3 and then Z3 doesn't have any subgroups, right? So we can consider this. Okay. Right. So what you should do for homework, okay, is the following. And you should do it because it's doable. Okay. What you do is you take this and this, and you know what omega is here. You take this extension
Hmm.
and try to prove that the automorphisms of this is what you said, set 3.
Okay.
Right? You one by one you would see what are the choices, what are the options, and that group will be order 3. Then just use your knowledge of group theory and do it. Okay.
Okay.
So that is something which you should do. And it's very nice. So this is simple. And then, so maybe in a few days, after a few classes, you will learn something called Kummer extensions, or maybe Kumer extensions. I mispronouncing it. And if I am not wrong, there is a generalized version of this, something to do with this, and there are some other conditions in the base field. Then it comes. So it's a very nice thing, and actually these are called cyclic extensions because the subgroups are cyclic. Okay, and then there are very interesting theorems like there is Hilbert theorem 90, Kumer extensions, and yeah, yeah, there are whole subjects coming out of it. So you will be doing your thesis in this. So these are the starting points, I think. And there are more things, but I actually don't know much Galois theory. So, anyways, let's sorry, let's look at this extension. But this time we will, of course, be careful. We will make sure that we, yeah, actually, let's have some fun. So, let's not add it, and then we'll actually have some fun because so these are actually just toys. One should not be afraid of these things. One should just pick up the pen and do, and then see where it takes you. Like I don't know what will happen, but I'm just trying it. Okay. So you take this, and now let's see what is the. And this will also not be very interesting, actually. Yeah, and that is because this is how it is. So, so now can you tell me what will this group be?
There's 6 roots of it.
6 roots, but there are only 2 choices. So it will be Z2. So you're thinking in the wrong direction. You are thinking from a direction of maybe you're seeing 6 roots and you're saying, oh, there are 6 roots. Don't think negatively. Just see what options you have. There are 2 options only, right? Because root 6 cube root of sorry, sixth root of 2 can only go to sixth root of 2 or minus sixth root of 2. Other options are there, but they are not there in your extension. Complex
Yeah.
numbers are not here. So it's actually simple. You have to think in that way. What is there? Just think neutrally, approach neutrally, just see what is there. And just, and when you see an obstruction, then you think about the obstruction and then you think how to overcome it. Okay. So, anyways, it's very simple. It is this. But then now something interesting might happen still. Can you tell me some sub extension of this, which we have actually done earlier? So, yeah, this is a slightly vague question, so I will write it. This. Ah, this is in between, right? Means this is containing.
Yes.
Good. Yeah. So you're sure, right, that this thing contains this. After raising it
Yes.
to third power, that cube root 6 root of 2 will. Good. So, anyways, you get that. Now, for this, what are the automorphisms? You have already done. It is again just set to
Hmm.
nice. Now you see
Hmm.
something. Now again, this is something bad. Means this is something uh, which is not a bijection. Something is failing, right? That this extension gave you this subgroup. Now you take a sub extension. It is giving you the same subgroup. It is giving you the same group, not a proper extension is not giving you a proper subgroup.
Yeah.
Okay, so you see bijection. So in this case, you cannot hope for a bijection. What bijection I'm saying? I'm just saying that like subfields and so field extensions, or rather, I should have said initially sub extensions. Well, not actually sub extensions. Yeah. Anyway, let me not put adjective and all that. It's just what I was, if you see, what I was trying to hoping in the beginning is that something like this, we will take a subfield. Okay, then we will get a group. Then from that group, I will take I will go back and get a field, right, by this process. And I was hoping that I will get the same field.
Same field in the sense.
Same field. So if I start with F prime, I take this, I get this subgroup. From this group, you have described a process to go back to a subfield, and we means if everything is nice, we hope that you will get the same field back, F prime back. Okay, meaning that if you take this as your H, right,
Okay.
then this fixed field of H should give you F prime back. That's what you would have.
Yes, 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 yes,
That is what
yes,
should
yes.
happen in the best case. Like if you have heard of something called Galois correspondence, I mean, you may have flipped the pages and seen, right? There is a Galois theorem written there, right? That says that you take a subgroup, or if you take a subfield and you go to the corresponding subgroup by this process, then from the subgroup, when you come back to get a subfield, you get back the same field subfield which you started with. That is Galois theorem, right? In
Hmm.
Galois extension that happens. But let's look at this situation. Well, you see, if I take this thing and I come forward, I get this. Okay. Now, if I take the fixed field of this, where do I go? Well, actually, you will go back here. That mm, you can probably see that. So if you take, okay, so we take Q root 2 and the automorphism is Z2, that is fine. But if you take Z2 and look at the fixed field of Z2, then I am saying that, okay, I don't know what I'm saying. Let's see what you get. Yeah, so what is the fixed field of this?
Okay, all those A, take the element A,
Yeah, all the A such that,
sigma of A goes to A, where all sigma belongs to automorphism of that one.
right, yeah, sigma of A, yes,
All
right, yes, sigma is in, yeah, that is the definition, but what is it? That is the question. What is the actual subfield you get? I have written something wrong here. That is the problem. I'm sorry. Yeah. Yeah. I'm sorry. That is why I'm getting confused myself. Yes, so you see, the mistake is that I should not be writing this, right? That's what we said in the beginning. We should be writing, uh, right? We should be writing this over q root 2. That was the original thing.
Yes, yes, yes.
Yeah, you remember, right? It was not that what I wrote, that was wrong. Yeah. And yeah, that is wrong. So now what is this?
Um, Z2 again.
Why then? No, no,
6
it will not be Z2. It
root
will
2 and
no, no,
6
no,
root
no.
2 and
No, no, it will not be because this has to this if it goes to this, how is it that you are just saying like that, right? If this goes to minus, it cannot happen because this is the only other option, right? Either 6. So you will have these two options, this or this, right? This cannot
yes.
happen because this will imply that square root of 2 goes to minus square root of 2. But you want square root of 2 to go to square root
Oh,
of
that
2.
is already fixed.
So
Yeah.
that's why it's actually identity.
Oh,
Okay. So it is simple. One has to do it. Then, okay. Yes, but again, you can see the phenomena in action. What is this? Yeah. So, but you see the problem is there, right? So if you took q root 6 over q, you will get z2. If you took q root 6 over q root 6, that will give you identity, right? As you said in the beginning. But q root 2 over q root 6 over q root 2 is also giving you the identity.
mm.
Okay, so that is a problem.
Problem.
Meaning that it's not a bijection, right? Both these subfields are giving you the same subgroup. Yeah, I have not defined the actual problem, but two subfields are going to the same subgroup. Okay, so if this happens, then you cannot expect what we were asking here. F prime goes to this and this should come back to F prime, right? So anyways, yeah, so because it's not injective, right? So how can it be bijective? But anyways, we'll get there slowly. Uh, yeah. Now let us see. So what is the fixed field of this? Yeah, it is going to be everything, right? Right? Sixth root by q root 2. I mean, you have a definition and everything, but you know that the answer is this. Because this is just identity, no? So fix of identity. What elements are fixed under the identity morphism? Everything, no? Right. So,
Yes.
hey, right, that's it. I mean, it's all, that's all. So the fixed field of this is this. Okay. So, so here we have seen a situation where you can think like, okay, you start with q root 2 and you get this sub extension. When you ask for the fixed field, you don't get q root 2, but you go to a different place. You go to get a different subfield. Okay.
Mm.
So this is a problem. Okay. So now can we use this example to say anything more? We can. Yes, but it is not very. Would be very interesting. Yeah. So let's not say anything more about this example. Let's stop it here. Okay. So we have seen the different things. Uh, yeah. Then just take maybe some more examples. So what should we do next? Just follow the book linearly. Till where have you read?
I've done page number
Page number.
18.
What exercise or what proposition?
Yeah,
8.
that is, I have done lemma 2.9.
Oh, you have question. Good. So let's then forget, let's not go to 2. Let us solve some problems of section 1, right?
Okay.
Because have you done many problems? Let's
From the
do,
exercise?
yes, of course.
No, no.
Yeah, that's what you have to do. So let's try. Okay, let's try the last problem, maybe last 2 problems. Okay. So where should we do? Should we have to wait on Zoom? So let's just do that on Google Meet. Okay. Yeah.
Yeah,
Same
okay.
link. You have a link, so we'll just
This is.
do there and finish it off.